Hello, hello. So today we're going to take some practice at writing different chemical equations from sentences. I don't think we'll balance them in this video. Maybe I will see if I get carried away. Maybe I'll bounce the last one or something. And we'll identify what kind of chemical reactions they are. But what I want to do first, before we start writing chemical reactions, is just take a couple minutes to talk a little bit about diatomic elements. Diatomic elements. Diatomic elements are any elements that in nature are found in pairs. So di meaning two, atomic meaning atoms. So any element found in nature in pairs. So elements found in nature in pairs. And normally we tell you to memorize these, and it's not a big long list. It's honestly 7 of them. Those 7 are hydrogen, oxygen, fluorine, iodine, nitrogen, chlorine, and bromine. And the easy way you might memorize this is just think of the word Hoffenberkel. Hoffenberkel. Now, it means nothing, but it sounds like a dumb scientist name. And it's how I've been memorizing my diatomic elements since the 9th grade, and it's never failed me once. So just remember, no matter what you're doing, if it is not bonded to something, if these elements are not bonded to something actively in a compound, they're not part of something, they will be in pairs. And we'll see what that means in a couple minutes as we move on through to our practice problems. So starting with the first one. Ammonia gas reacts with oxygen gas to form gaseous nitrogen monoxide and gaseous water. You'll notice we're starting to say gaseous, solid, liquid. And when we write chemical reactions, we actually have little symbols. So gaseous is generally represented with a little G. Solid will be represented with an S. Liquid will be represented with a lowercase L, cursive. And it'll be the only one that's in cursive, just so hopefully you don't get it confused with a 1 or something. And then you'll see aqueous, which is AQ. Aqueous. I think I have aqueous somewhere, so I know how to spell it. And that just means it is in a solution of water. So it's been dissolved in water. So we'll actually use those in these chemical reactions. So starting off with our basics, we have ammonia reacts with oxygen. So we already know that these are going to be our 2 reactants, ammonia being NH3 and reacts with, so we'll do a little plus, and oxygen being O2. And that's right, because it's my diatomic element that we just learned out. It's the O in Offenberkel. So to form, generally we say reacts to form. All right, so then we have our nitrogen monoxide and water. So those are going to be our products. Now we have to kind of remember our covalent bonding nomenclature. Now, because I see a prefix, I know I'm using my nomenclature. And another quick hint about this is that nitrogen doesn't have a prefix, which in covalent bonding means nitrogen's going to only be one of them, and one O, that's nitrogen monoxide, and water, H2O. So really quick, you might think, well, where do those fancy little gaseouses come in? Well, you just put them at the end right here. A little G, a little G, a little G, and a little G. And there we've got our chemical reaction. Again, I said I'm not going to balance these, so I'm really not going to. All right. Up next, we have propane gas reacts with oxygen gas to form gaseous carbon dioxide and gaseous water. It looks like everything is a gas again, but this time we're given propane. That's C3H8. Now, real quick aside, prop in organic chemistry means 3. Ane means there's no double or triple bonds, so it's going to be C3H8. You can generally just know that, but you don't have to, don't worry. With oxygen gas, O2 again, to form gaseous carbon dioxide, CO2, and gaseous water, H2O. I'll try and actually keep my colors consistent between my reactants and products. Real quick, we can also kind of talk about this is a combustion reaction. We have a carbohydrate, a hydrocarbon reacting with oxygen to produce CO2 and water. Standard parts of any combustion reaction. And then I'll throw in those little G's to represent gas. All right. Aqueous hydrofluoric acid. So now we're given hydrofluoric acid, HF, reacts with silicon dioxide. Those are two nonmetals, and I have my di, meaning that I'm definitely going to have to use my prefixes. SiO2, 2 comes from di, and reacts to form gaseous silicon tetrafluoride. So again, no prefix in front of the first one means it's 1. Tetra means 4, so that's going to be F4. And liquid water, H2O. So now I get to use some of the fun ones. I've got a little AQ on that. Silicon dioxide, I'm guessing it's going to be its solid form, but we don't really have what it is. Silicon tetrafluoride is going to be our gas, and water is going to be a liquid. All right, moving on to the final one. And I think I said I will balance this one, so we can do that too. Solid ammonium nitrite. So we really got to remember our polyatomics or be able to look them up. Ammonium is NH4 plus, nitrite is NO2 minus. So this will be NH4NO2. Is heated and produces. So it's not reacting with anything. We're just adding energy into it until it starts making nitrogen gas, which is N2 because it's the N in Hoffenberkel, plus H2O, and that's water vapor. So I know that's going to be a gas too. All right, so for this last one, I definitely said I'll balance it. So let's go ahead and do it. And you'll notice this is actually a decomposition reaction. So one thing breaks up into two other things. So we have N, H, and O. We've got 2 on our left side, 2 on our right side, 4 on our left side, 2 on our right side, 2 on our left side, and 1 on our right side. So I can clearly see that my nitrogens are good to go, so I don't need to worry about them. Hydrogen, just multiply by a 2. I'll find hydrogen on my product side right here. And that 2 is going to affect my hydrogen, making that come out to 4. That's balanced. But that 2 is also going to affect my oxygen. So I'm no longer at 1 oxygen, but instead I am at 2 oxygen. And lo and behold, I'm balanced with 1 easy step. I honestly thought it would be harder, but there you go. This is how we write equations. One quick thing I just want to go over is sometimes we don't need to give you the products. If you watch the types of reactions, we don't always need to do that. So maybe for one reaction, I'm saying HGO undergoes decomposition. So how do we write this? Well, HGO, mercury oxide, undergoing decomposition means it's going to break up. And there's only 2 elements it can break up into, Hg and O. And then the quick thing we need to do here is realize that O is O2. And there we go. We've written our reaction. If you want to get all fancy about it, you can balance. We can throw a 2 here and a 2 here, and that balances it out. One more example of where we don't even have to give you the products is, let's say, aluminum plus hydrochloric acid undergoes single replacement. And produces hydrogen gas. Now that we've given one of the products, we know what's being replaced. So we just write aluminum plus HCl reacts to form? Well, we know we're going to form hydrogen gas, which is just hydrogen. And remember, diatomic 2. So if hydrogen got kicked out of this reaction, that means aluminum came in. And so we have AlCl3. Now, you do have to remember that aluminum has a charge of 3+ as an ion, chlorine as 1-. So you need 3 chlorines to equal 1 aluminum. So that's why it's AlCl3. So hopefully this helps you kind of figure out how reactions are written, maybe figure out how to predict a reaction possibly. And yeah, have a great day.